This lesson is on chapter 8.2, solving systems of equations algebraically. Recall a system of equations. We can have 0, 1, 2, or an infinite number of solutions depending on what type of functions we have in our system. We can solve systems of equations algebraically using substitution or elimination. Those are methods that we saw in Math 10C with linear systems of linear equations. First example, solve the following system algebraically. X squared plus x minus 2y equals 0 and 5x minus y equals 10. We're going to do it both ways. We're going to do it by substitution and by elimination so that you can see both methods. Now, if we look at these equations, they're a little bit different than linear equations. So with linear equations, we have two variables, and each variable only appears one time in the equation. With quadratic equations, we have two variables, but one of the variables is going to usually appear more than once in our equation. So if we look at our first equation, we have x appearing in the x squared term and in the x term. So we have that appearing twice. So a note that we need to put for systems with quadratics, we must isolate or eliminate the variable that appears only once in each equation. Okay, and in a lot of our systems, if it's xy, that's typically the y value. So let's write a note maybe at the top of our page here. For systems with quadratics, we must isolate / eliminate the variable that appears only once in each equation. Okay, so let's try this example here. Because the y value is the one that is only appearing once in each equation, we are going to isolate the y when we do substitution, and when we do elimination, we're going to eliminate the y value. First, substitution. So I'm going to isolate the y in the linear equation. Let's start with that. 5x minus y equals 10. I want to isolate the y value, so I'm going to add y to both sides, and I'm also going to subtract 10 from both sides. So I'm switching the y and the 10 essentially. And then I get y equals 5x minus 10. Next step, after we've isolated the variable in one of the equations, is now this thing represents y, because it's y equals 5x minus 10. So we want to sub into second equation for y. Our second equation is x squared plus x minus 2y equals 0. So I am subbing in right there where my y is. Then I get x squared plus x minus 2 times 5x minus 10. So I'm putting that in brackets because that negative 2 needs to be distributed in. Okay, negative 2 distributed into those brackets. X squared plus x, negative 2 times 5x is negative 10x. Negative 2 times negative 10 is positive 20 equals to 0. Combine our like terms. We have 1x and negative 10x. So x squared minus x, take away 10x is negative 9x plus 20 equals 0. Okay, we're going to pause there and jump over to the elimination method until we get to the same equation. Elimination method. We want to eliminate one of the variables from both equations. The one we have to eliminate is the one that shows up once in each equation. So in this case, that would be the y value. To eliminate, we need to have the same number of that variable in each equation. Right now, I have 2 y's, or negative 2, doesn't really matter, and I only have 1 y in this one. I'm going to multiply my linear equation by 2. That's my first step, so that I can get the same number of y's in each equation. 2 times 5x minus y equals 10. I multiply that 2 in, and we get 10x minus 2y equals 20. We have to make sure our two equations are ordered the same way. So we have our x squared value first. There is no x squared in our linear equation, so we can say that it's first. Then we have our x term in both equations. Then we have our y term in both equations, then the equal sign, and then we have our constant term after the equal sign in both equations. So they are set up the same way. We don't have to rearrange anything. I'm going to write my second equation below, x squared plus x minus 2y equals 0. Now we want to decide if we should subtract or if we should add. So you want to look at your variable that you're trying to eliminate. Negative 2 and negative 2. If I add negative 2 and negative 2, let's just use our calculator because a lot of students make mistakes with this. So we want to have negative 2 and negative 2 end up being 0. So if I go negative 2 plus negative 2, it equals negative 4. So I should not add because that's not going to get us to 0. Negative 2 minus negative 2 gets us to 0. That tells me that I need to subtract the two equations. Everything in the equations I'm going to subtract. I have 0 x squareds in the top equation, in the linear equation. 0 x squareds. Take away 1 x squared. You can use your calculator if you need to. 0, take away 1. Negative 1. So we have negative 1 or just negative x squared. Then 10x, take away 1x. 10 take away 1 is 9 plus 9x. Negative 2, again, negative 2 minus negative 2, we get 0. So the y's are just completely gone. We don't write 0y, we just leave it blank there. And then 20 take away 0 is 20. Now we're going to move everything to one side. So I'm going to add x squared. Doesn't actually matter what order you do things in. I'm just going to make it so that this, my final equation, matches my equation from the substitution method so that we see that we get to the same place. So I had a positive x squared, which normally I prefer when I'm moving things to make my x squared positive anyways. So I'm going to move my x squared and my 9x over, adding x squared and subtracting 9x on both sides. And then we get 0 equals x squared minus 9x plus 20. So we see that we get to the same place with our two methods. We get to this single quadratic x squared minus 9x plus 20 equals to 0. Next step, so same step for both of these because we're in the same spot here, would be to solve 0 equals x squared minus 9x plus 20 by factoring or quadratic formula. If it specifically says to do it one way, then you do it that way. If it does not, then either way is fine. They're both solving algebraically. Okay, so I'm going to solve by factoring for this question. I'm starting with our equation x squared minus 9x plus 20. That's a basic trinomial. I want two numbers that can multiply to give me 20, and they can add to give me negative 9. I happen to know that 4 times 5 is 20 and 4 plus 5 is 9. We know that they both have to be the same sign because they multiply to a positive number. So they're either both positive or both negative. Looking at what they add to, since they add to negative 9, they would both have to be negative. So if 4 times 5 equals 20 and 4 plus 5 equals 9, negative 4 times negative 5 equals 20, and negative 4 plus negative 5 adds to negative 9. Those would be my numbers. Then I can write my factored form. X minus 4 times x minus 5 equals 0. Then I can get my x values. So if I solve x minus 4 equals 0, I have to add 4 to both sides. I get x equals 4. Same thing for x minus 5 equals 0. I have to add 5 to both sides. So I get x equals 5. Those are my x values. Now, what I want to do with those are the y values for each of those x values. Starting with x equals 4, I need to take x equals 4 and substitute it into one of our equations from the question. I'm going to use the linear equation, so it's less work. And I rearranged the linear equation when I did substitution. Y equals 5x minus 10. So I've already isolated the y. So I'm going to use that. I'm going to start with y equals 5x minus 10 and substitute in the 4. So 5 times 4 minus 10. Y equals 20 minus 10. 20 minus 10 is 10. Y equals 10. Next, we're going to do the same thing for x equals 5. Starting with y equals 5 times the x value, which is 5 minus 10. Calculating, 5 times 5 is 25. Minus 10. 25 minus 10 is 15. Then we have our solutions, which are when x equals 4, y equals 10, and when x equals 5, y equals 15. Last step, it asks us to verify our answer. That just means to substitute in our solutions, x and y, into both equations and make sure the left side is equal to the right side, as we did in 8.1. Starting with the point 410, first equation was 5x minus y equals 10. I'm going back and using the original equation. 5x, which is 4, minus y, which is 10, equals 10. 5 times 4 is 20, minus 10 equals 10. 20 minus 10 is 10, which equals 10. That's true. Now for the quadratic, x squared plus x minus 2y equals 0. X squared, so 4 squared plus x, which is 4, minus 2y, which is 10, so 2 times 10, equals 0. That gives us 4 squared is 16, plus 4 minus 20 equals 0. This is 20 minus 20 equals 0, 0 equals 0. True. Next point is 515. Do the same thing. Sub the point into our equations. First equation, 5 times the x value, which is 5, minus the y value, which is 15, equals 10. 5 times 5 is 25, minus 15 equals 10. 25 take away 15 is 10, equals 10. True. And last one, the quadratic. We have x squared, 5 squared, plus x, plus 5, minus 2 times the y value of 15, and it should equal 0. 5 squared is 25, plus 5 minus 2 times 15 is 30. 25 plus 5 is 30, minus 30 equals 0. 30 minus 30 is 0, which equals 0. True. So we solved the system algebraically. We did it both by substitution or by elimination. We saw that in both cases we get down to the same singular quadratic equation, and then we need to solve that algebraically either by factoring or using the quadratic formula. In this case I factored. Not all quadratics are factorable, as we know, so sometimes we'd have to use the quadratic formula, or maybe you just prefer the quadratic formula. Either way, we get x values of 4 and 5. We substitute those into one of our equations to get our y values of 10 and 15. So we have our solutions 4, 10 and 5, 15. And then we verified our solutions by subbing each of the points into each of the equations and checking that the left side equals to the right side. Let's try some word problems next. 14 more than twice an integer gives a second integer. The second integer increased by 1 is the square of the first integer. Solve the system algebraically. Well, in order to have a system, we would have to have at least 2 equations. So we need to come up with 2 equations from the sentences that we have here. Let's look at it piece by piece and see what it means. 14 more than. Thinking about more than. What does more than mean in terms of mathematical operations? That would be adding. 14 more than twice an integer. What is twice an integer? Twice means multiplying by 2. An integer could be an x or a y value. Okay, so we're multiplying something by 2. Let's say that it's 2x. We'll call that integer x. And that gives a second integer. Gives, in this case, would mean equals. Our second integer, we could call it anything, but let's call it y. Next sentence, so that would be one equation. We have 14 more than twice an integer is equal to our second integer. So 14 plus 2x equals y. Let's write that down. 14 plus 2x equals y. Next one, the second integer increased by 1 is the square of the first integer. Our second integer we said was y. We have to stay consistent with that. Second integer is y. Increased by 1. Increased, what does that mean? That would be adding, and in this case, we're adding 1. The second integer increased by 1 is the square of the first integer. Is, in this situation, is like gives. Gives and is represent equals. Then the last part, the square of the first integer. Our first integer was x. The square of the first integer would be x squared. In our second sentence, we then have y plus 1 equals x squared. So that's our second equation. y plus 1 equals x squared. Now we can solve by whichever method we like, substitution or elimination. I often do elimination, but this time I'm going to do substitution. I already have one of my variables isolated. In the first equation, I have that y equals 14 plus 2x. So make substitution easy. I'm going to substitute this portion, 14 plus 2x, into my second equation for y. So instead of writing y plus 1, I'm writing 14 plus 2x plus 1 equals x squared. Then there's nothing being multiplied to my brackets, so in this case I can just drop the brackets. 14 plus 2x plus 1 equals x squared. And then I want to simplify, move everything to one side, combine like terms. I'm going to move everything to the right because I like keeping my x squared positive, especially for factoring. I need to have my x squared be a positive value. So I'm going to, first of all, add 14 and 1. We get 15 plus 2x equals x squared. Just going to zoom in on this. Then I'm going to subtract 15 from both sides and subtract 2x from both sides, which gives us 0 equals x squared minus 2x minus 15. Now I would either factor or use the quadratic formula. I'm going to factor again. This is a basic trinomial. I need two numbers that multiply to give me negative 15, and they need to add to give me negative 2. I know that they're going to be different signs because they multiply to a negative. So one number is positive, one number is negative. I also know the negative number has a larger absolute value because it's that they add to a negative, so the larger number has to be the negative one, okay? So numbers that multiply to 15. 1 and 15, 3 and 5. Those are our only options. 3 and 5, if I make the 5 negative and the 3 positive, those would add to, multiply to negative 15, and they would add to negative 2. Then I can write my factored form. 0 equals x minus 5 times x plus 3. Then I can find my x values, solving each of these factors, these binomial factors. We'd have to add 5, x minus 5 equals 0, add 5 to both sides, x equals 5. X plus 3 equals 0, subtract 3 from both sides, x equals negative 3. Now that we've found our x values, we can substitute in to find our y values. We need to use one of our equations to substitute in our x values. So I'm going to use the first equation again. I already have y isolated, so it's easy. I'm going to put y equals 14 plus 2 times positive 5. And then I'm going to solve for y. 14 plus 10, y equals 24. And the second one, when x is negative 3, so this was for x equals 5. And now we'll do when x equals negative 3. Y equals 14 plus 2 times negative 3, y equals 14 minus 6, y equals 8. So our solutions are when x is 5, y is 24, and when x is negative 3, y is 8. Next word problem. A Canadian cargo plane airdrops a crate of emergency supplies. The crate's height above the ground after t seconds in free fall is given by the equation h equals negative 4.9 t squared plus 900. The crate's height above the ground after t seconds once the parachute is open is given by the equation h equals negative 4t plus 500. How long after the crate leaves the aircraft does the parachute open, and at what height is it? Round your answer to the nearest tenth. So what it's asking for is, let's say this is our first equation and this is our second equation. It's asking when is equation number 1 equal to equation number 2, or what are the solutions to the system? So at what time does the parachute go from closed to open? You can do substitution or elimination. I'm going to do substitution again in this case because they're both already equal to h. So I can just write them equal to each other, right? If they're both equal to h, then we can just write them equal to each other. So we have negative 4.9 t squared plus 900 is equal to negative 4t plus 500. I want to move everything to one side. I'm definitely going to use the quadratic formula because I have big numbers in the hundreds, and I have a decimal. So I'm not going to try to factor that. I'm going to use quadratic formula. So it doesn't matter if your t squared value in this case is a positive or a negative if we're using quadratic formula. So I'm going to add 4t and subtract 500. This gets me negative 4.9 t squared plus 4t plus 400 equals to 0. So now we need to solve for our t values by quadratic formula. We have our quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Sub in our values. In this case we have t equals, our b value is 4, our a value is negative 4.9, and our c value is 400. In this case our x is called t, negative b, negative 4, plus minus square root b squared, 4 squared, minus 4 times a, which is negative 4.9, times c, which is 400. All of that divided by 2a, which is negative 4.9. Okay, it does not want an exact answer. It wants us to round. So we don't need to simplify. We can just plug this whole thing into our equation. We would have one answer for the positive, the adding of the radical, and one answer where we are subtracting the radical. Let me bring up my little calculator here. So -4 plus, actually I'm going to put brackets because not all TIs can enter numbers in fraction mode. Some of them can, but not all. So if I want to enter this as a fraction and all of that stuff on the top as 1, I'm going to use brackets. -4, I'm going to do the plus first. Plus, square root, second function x squared to get square root. I'm going to do another set of brackets because I want to tell it that I want all of this under the square root. 4 squared minus 4 times -4.9 times 400. Close the brackets, that's all under the square root. Then close the bracket again because that's, can do delete. If I can find delete, there we go. I'm going to move over so I'm out of the square root now and then hit my second bracket. Then I'm going to hit divide. And now I want to divide by both of those, that product I want to divide by. So bracket 2 times -4.9, close bracket. So it's going to make sure that everything that should be on top is done together and then it's divided by the product of 2 times -4.9. Hit enter and we get -8.6361. We're going to repeat that process, but we're going to add the radical now and let's see, there we go. So I hit enter with the TI. I don't think all TIs can do this, but some of them can. So, oops, I don't want to change that one. I want to change the one in front from a plus to a minus. And then instead of re-entering the whole thing, I can just change that. And we get 9.4524, etc. Okay, so thinking about what these answers mean. Well, it's T for time, so this is a time. Can we have a negative time? Nope. So that's out. Can't have negative time. So the only solution that makes sense in this case is a T value of 9.4524 ... We need to find this would be the time in seconds, I believe. And we also need to find the height at which the parachute opens. So we know that it opens at 9.4524 seconds. We need to find the height that it opens. So I need to sub this in to one of my equations. I'm going to choose equation 2. It was h equals -4t plus 500. I want to take this value and put it in for t. H equals -4 times 9.4524 ... plus 500. Going back to my calculator. I already have that answer there, so I can just go -4 times second function, the little negative button here gives me the answer. So if I do second function that, it takes the last answer, and then plus 500, hit enter, and it calculates 462.19. H equals 462.1901 dot dot dot. So our solution is 9 point, rounded to the nearest tenth, 9.5 and 462.2. And what does this mean? The parachute opens at 9.5 seconds at a height of 462.2 meters. Solve the following system of equations algebraically. 6x squared minus x minus y equals -1. 4x squared minus 4x minus y equals -6. I'm going to do elimination this time. I notice that my equations are already in the same order. X squared, then x, then y, then equals, then constant. I also notice that I have the same number of y values. I have -1y and -1y. So I don't need to multiply either equation. I just need to decide if I'm going to add or subtract the two equations. So if I went -1 plus -1, I would get -2. That does not equal 0, so I'm not going to do that. -1 minus -1. Hey, look, that equals 0. That tells me that I have to subtract my two equations. 6x squared, take away 4x squared, gives me 2x squared. -x, so -1x, minus -4x. We can use our calculators. Negatives are sometimes confusing. -1 minus -4. When we subtract a negative, it becomes adding. So we're taking -1, adding 4. We get 3 plus 3x. -y minus -y. We saw -1 minus -1 was 0. So those are gone. -1 minus -6 is 5. We're going to move everything to one side. So keeping the x squared positive, I'm going to subtract 5, subtract 5. We get 2x squared plus 3x minus 5 equals 0. I'm going to factor this quadratic to solve for my x values. It's not a basic trinomial. It's a complex trinomial. So first thing, do I have a common factor? 2, 3, and 5. No common factor. So I have to use the box method or decomposition. 2 times -5 is -10. We need two numbers that are going to multiply to -10, and they're going to add to our middle value, which is 3. Because the two numbers multiply to a negative, they have to be one positive and one negative. Because they add to a positive, the positive number would have to be the larger number. So numbers that multiply to 10. 1 and 10, 2 and 5. 2 and 5, if we make the 5 positive and the 2 negative, they're going to add to 3 and multiply to -10. Now we're going to use the box method. Draw your box, split it into 4. First box, top left, is your first value in the trinomial, 2x squared. Bottom right box is the constant term, -5. The middle two boxes, it doesn't matter what order, those are the numbers we just found, the 5 and -2, and we put an x with them because they represent the middle term of 3x. So 5x, negative 2x, or swap them, negative 2x and then 5x, doesn't matter. Now we want to common factor each row and column. So looking at the first row, the common factor between 2x squared and 5x is just x. Then looking at the second row, negative 2x and negative 5, the common factor is just negative 1. Then looking at the first column, 2x squared and negative 2x. Okay, so if you have one negative in a row or a column, if it's at the beginning of the row or the beginning of the column, which would be the top, then your common factor is negative. Okay, so if it was negative 2x squared, then I would make my common factor negative. But since it's a positive 2x squared, the first term in the column is positive, then my common factor is positive. So 2x squared, negative 2x, my common factor is positive 2x. And then 5x and negative 5. Again, I have one negative, but it's at the bottom of my column. It needs to be at the beginning of my column if my common factor was going to be negative. So this will be a positive 5 for my common factor, which gives us the factored form x minus 1 and 2x plus 5 equals to 0. X minus 1, 2x plus 5 equals 0. X minus 1 equals 0. Solve for x would be positive 1. Add 1 to both sides. 2x plus 5 equals 0. We're going to subtract 5 from both sides to get 2x equals negative 5, and then we're going to divide by 2 to get x equals negative 5 over 2. Those are x values. Now we need to solve for our y values. We're going to sub our x values into one of our equations and solve for y. I'm going to go with the second equation, 4x squared minus 4x minus y equals negative 6. No reason, just picking that one. I'm going to sub in my first x value, which is 1. So 4 times 1 squared minus 4 times 1 minus y equals negative 6. 1 squared is 1, so first term is just 4. Second term is negative 4 minus y equals negative 6. 4 minus 4, that's 0. So I get negative y equals negative 6. And if we switch those, then y equals 6. Adding y to both sides, adding 6 to both sides. Y equals 6. Now we want to sub in our other value. 4 times negative 5 over 2 squared minus 4 times 5 over 2 minus y equals negative 6. I'm going to go to our graphing calculator and plug that all in. 4 times bracket negative 5 divided by 2, close the bracket, and then squared. Then minus 4 times bracket negative 5 divided by 2, close bracket. That all equals 35. 35 minus y equals negative 6. We're going to add y to both sides and add 6 to both sides. So we're switching the y and the 6. We get 35 plus 6 equals y. 35 plus 6 is 41. Y equals 41. Which means that our solutions are x is 1, y is 6, and x is negative 5 over 2. as a negative. Negative 5 over 2 and y is 41. Last example for this lesson. Solve the following system of equations algebraically, round values to the nearest tenth. Y equals negative 0.1x squared plus 2x, and y equals negative x squared plus 39x minus 378. I notice that my equations are set up in the same order. I have y, then equals, then x squared, then x, then constant term. And I notice I have the same number of the y value. So I'm going to do elimination. We have 1y and 1y. So if I go 1 plus 1, I'm going to get 2. I need to go 1 minus 1 to get 0. I'm going to subtract the equations. 1y take away 1y, that's just gone. So 0 equals negative 0.1 minus 1. Negative 0.1 x squared, take away negative 1x squared. So negative 0.1 minus negative 1 gives us positive 0.9x squared. Next I have 2 take away 39. 2 minus 39 is negative 37 minus 37x. And then 0 minus negative 378 gives us positive 378. I do not want to factor this, so I'm going to use quadratic formula, which is x equals negative b plus or minus the square root of b squared minus 4ac all divided by 2a. Plugging in our values, x equals, so let's see here, we have a is 0.9, b is negative 37, and c is 378. Negative b, so negative 37 plus or minus b squared, negative 37 squared, minus 4 times a, which is 0.9, times c, which is 378, all divided by 2 times a, which is 0.9. Again, it says round values to the nearest tenth, so we don't need to give an exact value, which means that we can just use our calculator from here to get our answers. Plugging in negative bracket, negative 37, close bracket. I'm going to do the plus first, then I'll do the minus. Square root second, x squared to get the square root. I'm going to bracket everything that's in here. So one bracket for all of the square root, another bracket for negative 37, close bracket, then squared, then minus 4 times 0.9 times 378, close a bracket for everything that's under the square root. I forgot to put my original bracket, so I moved to the right, out from under the square root sign, put a closed bracket, and go all the way back to my beginning, and put an open bracket. So that's everything that's on the top of my fraction. Then I want to divide, bracket, 2 times 0.9, close bracket. So that tells it the calculator what's on the bottom of my fraction, hit enter, and we get 22.1464, etc. Hit enter again to get that equation back. Oh no, okay. Highlight the equation, then hit enter. This is only for some TIs. Casios, you can just go up and over and change your equation. Delete that plus, change it to a minus, hit enter, and we get 18.9646. Blah, blah, blah. Okay, so we found our x values. Now we need to solve for our y values. Take one of our equations and sub in our x values. So I'm just going to take the shorter one, which is the first one. Y equals negative 0.1 x squared plus 2x. I'm going to start with the 22.1464. Y equals negative 0.1 bracket 22.1464 squared plus 2 times 22.1464. So go to my equation or my graphing calculator, negative 0.1 times 22.1464 squared plus 2 times 22.1464. Enter, and I get negative 4.75. 7535, etc. Do the same for the second x value. Y equals negative 0.1 x squared plus 2x. We want to sub in the 18.9646 squared plus 2 times 18.9646. In our calculator, negative 0.1 times 18.9646 squared plus 2 times 18.9646. Enter, and we get 1.9635. Dot, dot, dot. Okay, so our solutions to this system, we want to round to the 10th place. Our solutions when x is 18.96, rounding to the 10th place, that 9 would get bumped up, which would bump up the 8, so 19.0, and then 1.96, so the 9 would get bumped up, and that would bump the 2 up again, so 2.0. And our second solution, x is 22.14, so 22.1 to the 10ths. Y is negative 4.75, so negative 4.8 to the 10ths. So we used elimination here. Got down to one quadratic function. We used the quadratic formula to solve for the x-intercepts of that quadratic function. We then solve for the y values by subbing those x values into one of our equations. That is it for 8.2, solving systems algebraically.